Alright, my loves, I hope everybody's doing okay. This video is for the second part of confidence intervals for means. So we're just going to run through a couple of examples and talk through the state plan do and conclude steps. It's real similar to what we did with proportions. It's just a couple of slightly different formulas and a little different conclusion. I hope you guys are okay. I miss you. It is nowhere near as much fun talking to the wall in my living room than it is talking to you guys in the classroom. I miss you guys a bunch. I hope all is well and you're taking care of yourselves. Alright, so let's talk through this one. So we know our same SPITIC. We've been using this the whole way through. You want to make sure in the state that you're saying the parameter, the statistic, and the confidence level. Then you want to go through and name your procedure. On the quiz from the weekend, if you turned yours in through today, I went ahead and graded it. So today being Tuesday, sorry, I went ahead and graded it today and give you a pretty detailed feedback in the comments if you haven't seen it. And one of the things that I found was a common thing that got left out was people forgot to identify what they were doing. So make sure that you are saying, okay, I am doing this one sample T interval for a mean, or I'm doing a 2 sample Z test for P. So just make sure that you're putting the label in there. All right, then we got to check our 3 conditions. The normal condition is different. Random and 10% still the same. That's easy. The normal condition is different. In the last video, we went through the 3 ways to figure it out, starting with the easiest, working to the hardest. We're going to do 2 examples of the hard way today, just to remind you how to do that in your calculator, and so you've had a couple examples. But the first way is, if you're lucky, they go ahead and tell you it's normal. So cross your fingers, you are so lucky. If not, the second thing you're looking for is your sample size. The central limit theorem says something is normal if it has 30 or more in the sample. So if your sample size is 30 or bigger, you're good to go. If you've got a small sample and they didn't tell you that it's normal, then you need to graph it. Usually histogram is your best bet. You could do a box plot too. What you're looking for is you want to make sure that you don't see any evidence of skew, so it's vaguely symmetric. I said symmetrical-ish in the notes because it doesn't have to be perfect. It just needs to be not skewed left or skewed right. And then you also need to not have any outliers. As long as those 2 conditions are met, then you can go ahead and say it's approximately normal and move on with your life. Then going through the do, you've got your calculations. It's the same setup that it's been. Your statistic plus or minus your critical value times your standard error. We're using standard error instead of standard deviation because we don't know the standard deviation of the population. We only know the standard deviation of our sample. So since we're using that, we're going to call it standard error. And you've got your formula there. The one other big change is that we're using T star instead of Z star. We went through how to find T star in the last video. That was using the same table as we were using for the Z star, but instead we're looking at the degrees of freedom, and then we're looking at the probability tail and figuring out then what our T star would have to be. And then the very last thing is this same conclusion sentence we've been writing for confidence intervals this whole way through. So one thing I did want to refresh your memory on, because it's been a hot minute since we've done this, but we're going to be actually working with the spreadsheets again in our calculator. So we're going to put data in our calculator, then we're going to run one variable statistics so we can find our mean and our standard deviation, and then eventually we're going to be graphing these so we can check to see if it's roughly symmetrical and doesn't have any outliers, so we can check and see if it's normal. So here are the calculator steps. I'm going to walk you through everything using the calculator so you can see the buttons I'm hitting and everything, but I did want you to have these steps written down as well, so they're here. All right, for most of these mean problems that I have seen in examples, they just give you the data set. They make you go through the step of finding your own mean and standard deviation. Kind of crappy, I know, but the calculator does most of the work for you. So let's go ahead and roll on that, but let's read this one first so we make sure we know what we're talking about. All right, so it says as part of their final project in AP Stats, Christina and Rachel randomly selected 18 rolls of a generic brand of toilet paper to measure how well this brand could absorb water. To do this, they poured 1/4 cup of water onto a hard surface and counted how many squares it took to completely absorb the water. Using the data below, construct and interpret a 99% confidence interval for the mean number of squares of generic toilet paper needed to absorb 1/4 cup of water. All right, so to me, that sounds like this was a situation where they were stuck at home in quarantine and were bored and were coming up with a project. But, so what we need to do before we do anything else is we need to find our mean and our standard deviation. All right, so we're going to use those calculator steps that were on the front. I'm going to talk you through it though, so you don't have to like flip back and forth. All right, so the first thing you want to do is you want to hit your on button, which is the home. All right, and then we want to click the spreadsheet looking one, which is right in the middle. Okay, then you need to name your data. So we're talking about absorbing toilet paper. So, and it's the number of squares of toilet paper. So I'm going to call this squares. It only lets you put in one word, so it doesn't matter what it is, just go with something so you know what it is. So we got squares. Okay. Then I'm going to type all my data in. All right, I did this problem already, so it remembered and pulled it up. Yay! Magic of calculators. All right, so there are 18 points in that data set, so you definitely want to, went way too far. You do want to scroll down, and you've heard me talk about this before, that proofreading is important. You also want to make sure you put in the right number of values. So there's 18, so I'm good. All right, so then to get our actual calculations, you're going to want to hit menu 4 1 1, and that's going to pull up our one variable statistic. We have one list of data. All right, and then you want to tell it what you're looking at. So we're looking at squares of toilet paper, and then you want your first result column to say B. It's just going to put it in column B. If you want to put it in column C, put C there. It doesn't matter. And leave everything else blank. All right, and then we're going to hit OK. And you're going to look at this and go, wait, I just put it in and it didn't do anything. It's because we're all the way down at the bottom at 18. So you got to scroll back up to actually see all your stuff. All right, so what we need are X bar and SX. So X bar is our mean. So our mean is 24.944. If you want to add the fourth decimal place, go for it. I just rounded to 3. And then for SX, same thing. I've got 2.859. All right, so now that we know those two pieces of information, we can just kind of truck through our steps. All right, so for state, first we have to talk about our parameter. All right, so we are finding the mean of a population. So that is mu. All right, so mu is going to be the mean number of squares of generic toilet paper needed. All right, the statistic is our X bar. So we just found that. So you just have to recopy it. And then our confidence level, they tell us they want 99% confidence interval. Oops. All right, cool. So that's our state. All right, moving down to plan. First thing we want to do is make sure we name this. So we say what procedure we're doing. So we are doing a one sample, of course. So it's one sample because we have one set of data versus what we were doing last week when we had two sets. So one sample t interval for mean. If you wanted to write mu there, you could do that too. It's fine, however you want to do it. All right, then we've got to run through our 3 different conditions. All right, so first off is random. And in the problem, they tell us it's randomly selected. So we're good there. All right, and then we're talking about 10%. 18 is most definitely smaller than 10% of all the total toilet paper rolls in the world. There are definitely more than 180 generic rolls, though apparently we can't find them in stores right now, but they definitely exist. Alright, so the normal is going to be a little annoying now. It's not large counts anymore. Okay, so first thing we want to check for is, did they say in the problem that it was normal? Unfortunately, not so much. Alright, second thing we want to check for is central limit theorem. So do we have more than more than 30 things in our sample? Unfortunately, we don't. We only have 18. So at that point, the only option we have is to go and graph it, to actually look at our histogram and see. All right, so what we're going to do that, we're going to hit that house again. We're going to hit on, and we're going to hit the bar graph right next to it. All right, so then down here, we're going to click on the x-axis, and we're going to say squares. All right, and so that gives us a dot plot. Just by looking at the dot plot, it looks pretty good. I don't see any evidence of skew. I don't see any evidence of outliers. There's not one point that's way off by itself. You can check a couple different ways. So if you hit menu and plot type, you can change your different graphs. So we're looking at a dot plot. If you wanted to look at a box plot, you could hit number 2 and it'll turn it in. To me, that looks pretty symmetrical. The left whisker is slightly longer than the right, but it looks pretty great. The other one, you can do menu, number 1, and you can look at your histogram. And so there's our histogram. Again, relatively symmetrical, not bell-shaped necessarily, but it's symmetrical. It's not really heavily skewed one way or the other. And again, no outliers. So based on that, we can go ahead and assume it's approximately normal. All right, so jumping into our do section now. I'm gonna actually run through this. So we're going to find a 99% confidence interval, which is the statistic plus or minus the critical value times our standard error. All right, so our statistic was our x bar. Our critical value is t star. And our formula for standard error is Sx over the square root of n. Okay, so our x bar was 24.944. All right, now we still need to find our t star. All right, so I'm going to do that work over here out of the way. I think it helps to write it down. So our degrees of freedom, it's our sample size minus 1. So 18 minus 7, I'm sorry, minus 1 is going to be 17. And then for our tail probability, it's 1 minus our confidence level divided by 2. So that's going to be 0.01. 0.01 divided by 2 is going to give us 0.005. So those are the two things we're going to need to use on our table to figure it out. So I'm going to jump to the table. All right, so our tail probability we said was 0.005. So that's right there. And then I want to find a degree of freedom of 17. So that's right there. So I'm going to go across till they match. And I'm going to get that, of course. Sorry, y'all. So I'm going to get that 2.898. Right there. Okay, so that's what we're looking for. So when we're finding our T-star, again, we need our degrees of freedom, which is 1 smaller than our sample size. And then we need to figure out our tail probability. So we subtract our confidence interval from 1, or confidence level from 1, I'm sorry, and then divide that answer by 2. All right, so we're going to end up with 2.898. This tablet is quite grumpy with me today. All right, then we're going to do our standard deviation, which was 2.859 over our sample size, or the square root of our sample size, so square root of 18. All right, so jumping back to the calculator, I need to hit the house so I can get back to the calculator screen. So we're going to hit A. All right, so we need 2.898 times our fraction. Oops. All right, so on top is 2.859. And then on the bottom is square root of 18. All right, so what we're going to end up with is 24.944 plus or minus our 1.953. All right, and when you do your addition and subtraction on that, that's going to end up giving you, slide over here a little bit, 22.991 and to 26.897. All right, so that's our interval. So the last thing we need to do is just write out our statement. So we are 99% confident that the interval bless y'all. From 22.991 to 26.897 contains the true mean. A mean number of generic toilet paper squares that needed to absorb a quarter cup of water. All right, so that is quite honestly as complicated as I can make one of these problems. So I gave you a data set. You had to go through and find the mean and the standard deviation. And then the normal, you had to go all the way through and looking at a picture. That's it. That's as many steps as I can throw at you. All right, so let's try looking at one more. If you want to pause this video, try example 2 on your own and then come back and check it with me. That's totally fine. If you'd rather hear one more example together though, that works too. All right, so I promise you, by the way, I did not make this example up. I found it. It's a little crazy. I feel like this is a Miss Willie problem. Biologists studying the healing of skin wounds measured the rate at which new cells closed a cut made in the skin of an anesthetized newt. Here are data from a random sample of 18 newts measured in micrometers, which are millionths of a meter per hour. So this is how fast their cuts are closing up. Alright, so they want us to calculate and interpret a 95% confidence interval for the mean healing rate mu. Alright, so same deal as before. First thing we need to do is find our x-bar and our standard deviation. Alright, so following those same calculator steps from the front page, we're going to go to a spreadsheet, and we're going to name it. I'm going to call this one growth. You can call it whatever you want, as long as it's not rude. Alright, so if I put that in as growth, I hit enter. Magically, the calculator remembers the numbers for me, so I don't have to type them back in. But just like we did on the last problem, scroll through, make sure, proofread, double check that everything you typed in is correct and that you have the right number. They tell us there's 18 newts in the problem, so we better make sure we have 18 values over here. And we do. Alright, so that's putting your data in. Now we want to figure out our spreadsheet, or our mean and our standard deviation. So we're going to hit menu 411. Alright, we got one list. We want to tell it what to find, so we want it to use growth. And you can leave this as C, you can make it B, it doesn't matter, whatever works for you. Alright, I got to scroll back up to actually see the numbers. Alright, so we need X bar and we need SX. So X bar is 25.667 and our SX is 8.324. So now that we have those, we can go ahead and start everything else. Alright, so for our state, we need to name our parameter, we need to name our show our statistic, and we need to say our confidence level. So for parameter, it is, mu, which is the true mean healing rate. For newts. Alright, then for statistic, we found that our X bar is 25.667 and our our confidence level is 95%. Alright, then plan. You gotta name what we're doing and then check the conditions. So we are doing a one sample T interval for mean. Alright, then we gotta look at our conditions. So for random, we're good. They said it was a random sample. For 10%, there are way more than 180 newts in the world. Alright, now normal. Let's go through the list from easy to hard. So easy would be they said it was normal. Unfortunately, they did not. Second is sample size. So is our sample size 30 or bigger? No, it is not. It is only 18 again. So that means we have to look at the graph. Alright, so to look at the graph, we're going to go back to our calculator. We're going to look at our house. We're going to tap the graph button. We're going to click on the x-axis and we're going to tell it that we're looking at the growth graph. Alright, so there's our nice pretty dot plot. It looks okay. there might be, with this point off here, off to the right, maybe a thought of that being an outlier. So there's a couple ways we can check for that. So first we're going to hit menu, plot type. So let's look at it as a box plot. Because if it was truly an outlier, remember these box plots would show the outlier as a dot. It doesn't. It's just showing a complete whisker. So that outside point wasn't an outlier, so we're good there. And looking at our box and whisker plot, there's a little bit of skew, but it's not heavy. It's not big. So we should be good to go. Let's check our histogram though, just to be sure. So yeah, I mean, there's no big sharp skew. It's not all piled up on one side. It's symmetrical-ish. I mean, it's not perfect, but it would work. We can make that happen. Alright, so we've got state covered, we've got plan covered. Now we got to do the thing. Alright, so it's stat, plus or minus, critical value, times our standard error. In symbols, that's x bar plus or minus t star times sx over the square root of n. Alright, we found x bar at the very beginning, so that was 25.667. Alright, now we got to go do a little work over here to find our t star. Alright, so we need our degrees of freedom, and that's our sample size minus 1. So 18 minus 1 gives us 17. For our tail probability, it's 1 minus our confidence level, which was 95%, and then divide that by 2. So that's 0.05. 0.05 divided by 2 would be 0.025. So we're going to use those two numbers and go check the chart to find our t star. Alright, so we're still doing 17, so that's fine. But now we're looking for a tail probability of 0.025. So 17 comes to the 0.025. And it gives us the 2.110. There we go. So that's what we were looking for. Okay, so we can take that back over to our chart. We're going to multiply it times the standard deviation, which was 8.324, and divide it by the square root of our sample size. Let's get our calculator back here. Jump back to the calculate screen. Alright, so we're going to be 2.11 times our fraction, which is 8.324. Dang. And then we're dividing by the square root of 18. There we go. Okay, so we get 25.667 plus or minus 4.140. And when we do our math, that's going to come out to be 21.527 to 29.807. So to conclude, We are 95% confident that the interval from 21.527 to 28.807 contains the true mean healing rate. For newts. Okay, so that's pretty much it. Things I could ask you to build onto this, I could say, so and so thinks that the mean healing rate is, 30. Does that make sense? And you could say, well, 30 is not inside our confidence interval, so no, we could rule that out. That's pretty much all you can really do with these at this moment. When we get into significance tests, we'll talk about how to do both pieces of that where you can start to do the comparisons. But for this one, that's pretty much all you can do is they can give you a value and you can say, yes, that value is inside my confidence interval, or no, that value is not. And that's it. That's all you're at. All right, my loves, I'm going to call it there for this one. If you have questions, please shoot me an email, post on a discussion board, send up a, solar flare, whatever you need, or signal flare, not a solar flare. Oh, I'm too tired for this video. So just let me know if you need help. I'm happy to get you guys whatever help you need. Homework answers will be up as soon as I can get them. The homework answers for the first part are already up. And I will talk to you guys later. Have a great day. Bye.